Hello everyone, today I'm going to introduce you guys to one of the antibiotics called ampicillin, a well-known and widely used antibiotic. It is a versatile bacter-lactam antibiotic that has saved lives since the 1960s. First, we look into source or origin. Ampicillin was first discovered in late 1958 and made available for commercial use in 1961. It was developed by Beacom, a pharmaceutical company based in the UK. What is interesting is that it is a semi-synthetic form of penicillin, meaning scientists modified natural penicillin by adding an amino group to the side chain. This change helped expand its action against a wider range of bacteria. Next, let's see ampicillin's structure and brief properties. Chemically, ampicillin belongs to aminopenicillin group, which has the formula C16H19 N3 O4 and S. Some key properties are: first, it is a water soluble; second, it is acid stable, which means it can be taken orally; next, it has a broad spectrum, meaning it works against both gram-positive and negative bacteria. This makes it useful in treating various infections. So how does ampicillin work? As you can see in figure 1, ampicillin's main job is to stop bacteria from building their cell walls. Bacteria cell walls are like protective shells. They are important for the bacteria's structure and survival. Ampicillin targets specific enzymes called penicillin binding proteins or PBPs. These PBPs all link together parts of the bacterial cell wall through a process called peptidoglycan cross-linking. When ampicillin binds to these proteins, it blocks that linking process, so the bacteria can't form a strong, stable wall. As a result, the bacteria become weak and eventually burst open and die. This process is called cell lysis. One example of a bacterium that ampicillin works well against is E. coli, which is a gram-negative organism commonly found in urinary tract infections. Like many antibiotics, ampicillin can become less effective over time because some bacteria develop resistance. One of the most common ways resistance happens is through an enzyme called bacta-lactamase. This enzyme is produced by certain bacteria and it breaks open the bacta-lactam ring in ampicillin, which is the core structure that allows the antibiotic to work. Once this ring is broken, ampicillin becomes inactive and can't kill the bacteria. You can actually see this process illustrated in figure 2 of my poster, where the enzyme targets and hydrolyzes the bacta-lactam ring in a resistant Streptococcus pneumoniae cell. Some bacteria also use efflux pumps, which simply push the antibiotic out of the cell, or they may change their PBPs, the proteins ampicillin normally binds to, so the antibiotics can't attach properly. An example of resistant bacterium is Streptococcus pneumoniae, which is known to have altered PBPs that reduce ampicillin's effectiveness. To fight back against resistance, ampicillin is often combined with clavulanic acid, which blocks bacta-lactamase and helps the drug works. Let's talk briefly about cost. Ampicillin is generally affordable. 250 mg of 10 capsules is cost around 4 ringgit to 7 ringgit, while 500 mg that contains the same 10 capsules is cost around about 6 ringgit to 12 ringgit. In hospitals, a bulk injectable packs cost around 147,000, while in laboratories, a 1 ml vial at 100 mg per milliliter is around 52 ringgit. So for regular use, it is considered low cost and accessible. To wrap up, ampicillin has been a trusted, affordable antibiotic since the 1960s and remains useful today if we use it wisely to avoid resistance. That's all from me. Thank you so much for listening. Goodbye.